I cordially welcome to you all for the webinar of Universal Intellectual Trust. A flower cannot blossom without sunshine, and man cannot live without love. As like us, function cannot start without welcome. Now I invite Dr. A.S. Ganesharajan, Chairman, to welcome the gathering.
Thank you, Prasan. Good evening to everyone present here. I am very happy to invite you all join for our ninth UIT webinar on design and development of PEM water electrolyzer, going to delivered by Dr. M. Sankara Rao, co-founder and director of Nanosol Energy Pvt Ltd, Hyderabad, Telangana. Universal Intellectual Trust is one of the non-profitable organizations which is focusing to develop education and scientific research. Education and scientific research are of the major tools for growing the intellectual society. So we strongly believe the society can make a modern world with a clean environment and utilization of renewable energy source. In this great manner, today's webinar is useful for utilizing renewable energy source and related discussions. I hope you all are going to enjoy this webinar. Before our expert talk, I would like to source some of our UIT activities and upcoming events. Please, please, can you see my slides? This is our Universal Intellectual Trust Forum website. In this forum, we have to give all clearance about our trust as well as our activities. So, if you interest, you go this www.uattrust.in. We are three found this trust. This is myself, Dr. A.S. Ganesh Raja. This is Dr. K. Rajkumar, Secretary of UIT. Dr. S. Chandrasekhar, Treasurer of UIT. We have three coordinators actively participate all events to coordinate and going good activities in UIT. Dr. Y. Sasikumar, Dr. S. Tirumurugan, and Dr. K. Vaityanathan. So these are the universal intellectual trust giving many activities like UIT webinars, UIT EQs with the prizes, UIT scientific news blog, UIT scientific expert talks, UIT publisher, UIT YouTube channel, and the scientific supports. This is our scientific news blog. In this blog, we have to publish some of the recent research related to energy and environmental, as well as we have to focus on field in sciences. This is our EQs conducted for many field, particularly chemical sciences, physical sciences, mathematical sciences, as well as we are planning to give some more EQs in specific field in chemistry, physics, mathematics, as well as other scientific fields. In this event, we not only give EQs questions, we are discussing with some experts. This is our first webinar on turning an idea into a pattern. This was delivered by Dr. K.T. Varkis. This is our second UIT webinar on wondrous world of one-dimensional materials delivered by Dr. L.R. Sobin, Department of Physics, SRM Institute of Science and Technology. This is our third UIT webinar on robotic research and future directions, delivered by Mr. Balaji Thiru, founder of Village Tech School and Tamil Robotics Clubs. This is our fourth UIT webinar on sustainable through thermoelectrics, delivered by Dr. Karthikeyan Vaityanathan from Hong Kong. This is our fifth EIT webinar on microplastics are everywhere, delivered by John Doibo from Singapore. This is our sixth webinar on drug development challenges, yeah, bioinformatics views, delivered by Dr. Princey. This is our 7th UIT webinar. It's delivered by Dr. Ratnesh Das from Dr. Hari Singh Gaur Central University, Madhya Pradesh. So this is our 8th UIT webinar on aromaticity concept for IIT JAM, CSR and GATE examination delivered by Dr. G. Rajkumar, Vivekananda College, Madurai. Today, 9th UIT webinar on design and development of PEM water electrolyzers. I already mentioned Dr. M. Chandrasekhar Rao from co-founder and director Nanosol Energy Pvt Ltd, Hyderabad. This is our upcoming 10th UIT webinar on turning waste to products, carbon capture using industrial waste. Ms. Leah Jacob from UAE. This is our YouTube channel, so all activities, UIT activities, are uploaded in our channels. When you have to time and when you have to interest to watch us, you can go UIT YouTube channel and watch all events. This is our UIT web publishers. We have to call one book with ISBN number, nanomaterials as photocatalysis, energy and environmental applications. So we have two experts for reviewers, Dr. K. Anbalakan from Pondicherry University and Dr. T.S.N. Sankara Narayanan from University of Madras. So these are the topics of interested to publish in this book. We have deadline to accept abstract. If you have to interest to write some chapters, you can contact us and send abstract to us. This is I am happy to introduce and welcome our upcoming UIT virtual conference on sustainable chemistry and renewable energy. So this will be conducted on end of February. So we are accepting speakers from very expected institutes, esteemed universities. So we hope this virtual conference will be useful for all research scholars, scientists, and students. So we also plan to call abstracts for oral presentation and poster presentations. So I hope it will be useful for all. We also associate with some institute to conduct some webinars and key quizzes. This is one example to associate with the Periyar Maniammai Institute of Technology. We also call some scientific experts from various field to give talk as well as some discussions. We also call scientific experts for discuss recent articles. So if you have to interest to discuss some recent articles from good impact factor journals like Nature publishers, we can arrange a seminar or webinar for those topics. So we also call e-content for our ISBN, for our SNB blog. We also call UIT volunteers from various institutes. We already have some volunteers from Alagappa University as well as National College Trichy. So thank you one and all. I hope you are all going to enjoy in this webinar. Thank you very much one and all.
Thank you, sir. Now I invite Dr. K. Rajkumar, sir. His PhD in Pondicherry University, Director of Viluppuram Educational Trust, Viluppuram, Guest Faculty, Central University of Tamil Nadu, and also he is the UIT Secretary for the introduction of the Chief Guest.
Rajkumar, you are not audible. Please unmute your mic. Yeah, please.
Audible, right?
Yes, now it's okay.
Welcome, Dr. Shankar Rao, for our UIT Intellectual Universal Intellectual Trust. So, with the introduction of Dr. Ganesh Raja, now I am going to invite our chief guest, who is a resource person from Nanosol Energy Pvt Ltd. He is a co-founder and the director of the Nanosol Pvt Ltd. Hyderabad, Telangana from India. So he is a resource scholar and research worker who completed his PhD in CSIR Sikri in Karaikudi, Tamil Nadu. So this is the institute where he completed his PhD. So with this electrolysis technique, he is going to represent this basic and as well as the instrumentation how he formed this one. So about his So he completed his PhD in Sikri under the title of Nanostructure Carbon Materials for Electrocatalysis and Sensor Applications. And he also got several awards related to his research work. Now he is organizing. He held a organizing member in international conference, and he also served the NPDF fellow. He also got a NPDF fellowship at the time of 2017, and he also got a travel grant award from the DST for the international conference and CSAR SRR fellowship, and he also qualified the GATE and the CSR NET in his academic career. So, come to the professional positions. He is a CTO and director of the present Nanosol Energy Pvt Ltd, and he also acts as an assistant professor in KL University, and he also worked as a Geetam Institute of Gandhi Institute of Technology and Management, and he completed his self in two institutes. One is GITIM, and another one is Indian Association of Cultivation of Science, which is in Kolkata. And he also worked as a research associate and SRF and JRF in his overall positions. So, especially the editorial member, he is also act as an editorial member and reviewer for the various journals. This is the International Journal of Material Science and Application and Material Today Proceeding, and International Journal of Material Science and Applications and Material Science and Engineering, so up to till date. And come to the overall research work from the 2014 to till date. So, the graphical representation and tells about his overall skills and the H index, which is a 10, and I10, which is a 11, which is a good impact as of with his overall career. So these are the important, highly cited papers from the 2016 to till date. So recently he is published 5 papers in the 2021 and 4 book work book chapters he completed, and so many international conference and the workshop he conveyed his research work. So we hope he will get a good position in future. Now I am welcoming the Sankara to his presentation. Welcome, Dr. Sankara.
Thank you, Rajkumar sir, for your nice introduction. And your team has done excellent work. Hello, is that audible?
Thank you for your acceptance. Just now
Yeah,
you can
audible.
able to start the
Please
video.
proceed.
Yes, sir. Yes, sir. Yes, sir. Thank you.
Thank you, sir. Now I request our Honorable Chief Guest, Dr. M. Sankara Rao, M.Sc. Ph.D., co-founder and director, Nanosol Energy Pvt Ltd, Hyderabad, Telangana, India, address the webinar.
Yes, sir. Is slide is visible, sir? My slide, my presentation.
Yes, yes, it's visible. Yeah,
Yes, sir. Yes, sir.
please.
Yes, sir. Thank you, Rajkumar sir, for your invitation. And your team is an excellent work to activate the young minds in different fields. From industry researchers. It's a nice job, sir.
Sir,
So,
just raise your audio, please.
yes, sir. Yes, sir. Is now audible, sir? Hello.
Yes, yes, audible, please.
Yes,
Yes,
sir.
sir. Yes.
So, welcome to Varunda for this presentation. So today I'm going to discuss about design and development of PEM water electrolyzer. So before going to this one, so what Nanosol will do, we can work on this cutting edge research. So like advanced technologies we are working from the conversion technologies. If you look at the gases of carbon dioxide, or sulfur dioxide, or methane, these are some waste materials. We convert it to the energy. So we are developing some uh, waste material like for best example, we can go for the bio waste, we get the biogas generation. So like this, we can work on this different conversion technology. I will explain that. Uh, so this is the overview of my talk. So overview of my talk is it is a completely advanced technology what we are going to do, discuss today. What we are going to discuss today is PEM water electrolyzer. It is a proton exchange membrane water electrolyzer. So here, the proton exchange membrane water electrolyzer is the first time we have designed in India. So across the globe, people are working. So in India, this step, this hydrogen recently reaches from the August 15th onwards. So where the Narendra Modi is inaugural speech, he delivered. So generation of green hydrogen, the generation of green hydrogen, hydrogen from the waste, from the renewable sources are different available sources. So here, so in this talk, so I am going to discuss about what is the hydrogen and what is its importance. So first of my talk I am going to discuss and what are the existing technologies are there for the hydrogen production technologies and later of this matter, I am going to discuss about what is PEM water electrolyzer, how it will work, and last this thing is how we are going to design this PEM water electrolyzer from a small scale to a final. So this is the my overview of matter. So why? So so what is hydrogen? So hydrogen is a, like a it is a just like a fuel. It is just like a fuel. If we go for this some places, we can get the petrol, diesel, kerosene. Some of the fossil fuels we can get it directly. So whereas the hydrogen is the secondary source. It is a hydrogen is present in number of places. Water will be there, carbohydrates will be there, carbon, all organic molecules. There is a hydrogen will be present. Without hydrogen, it's a very less to adjust a particular molecule. So our intention at the nation, so what the Make in India nation is to generate the hydrogen. We have to capture that one. We have to produce the hydrogen from the particular source. There is a water will be there. Water contains hydrogen and oxygen. So from that water we have to capture hydrogen. There is a methane, biomethane will be there. From methane, what is the formula of methane? It is a CH4. From that methane, we have to capture the hydrogen. So whereas this carbohydrate, it is a C6H12O6. There is a 12 hydrogens are there. Every carbohydrate molecule, what the food, what is all biodegradable items, it has some carbohydrate. So from that carbohydrate also we have to take the hydrogen. So that's why. So hydrogen is everywhere it is available. So we have developed the technology how to synthesize or withdraw the hydrogen from the particular molecule. That's why it's called as a widely available as a secondary energy source. So to come to this point, second one, hydrogen is a tasteless, a colorless, and odorless gas, and it's a simplest element. It's the first element in the periodic table. So the main one more advantage of this hydrogen is they have a good calorific value. Whereas the petrol, if taken the petrol, its calorific value is 40. So whereas if you look at the hydrogen, its calorific value is 120. It means it's having a high energy content by weight, three times higher than the existing petrol. So that is the one of the basic importance of the hydrogen. So that's why that Narendra Modi, all this government is initiating lot of programs for the past 1 year for the hydrogen projects, like a green hydrogen, blue hydrogen, and grey hydrogen like that. The green hydrogen and blue hydrogen, grey hydrogen is nothing but if the hydrogen is synthesized or prepared from the renewable sources, that hydrogen we can call it as a green hydrogen. So if we are adapting other than this renewable source, based on this thermal route or thermal, they will divide it grey hydrogen or blue, blue hydrogen like that. So here we are going to discuss about here some of the green hydrogen technology. So in addition to that, I will also touch some blue hydrogen and grey hydrogen technology. So this hydrogen, once you pass to the a fuel cell, it is a hydrogen electrolyzer, you pass the fuel cell, it will give the electricity and byproduct is the water. Coming to this one. Why this hydrogen is the fuel? It means if you burn the petrol, so what is the byproduct? There is a carbon dioxide and it will some other gas. Whereas if you fill this hydrogen car or hydrogen bus in the transport, it will give the byproduct as a only water. The byproduct is just like a water vapor. And at present, across the globe, almost 70 million metric tons of hydrogen is produced globally. There's a different types of hydrogen. There is a gray hydrogen, blue hydrogen. They use for the different applications. So in future, now people are working for this, increase this number. Every industry should be maintain a minimum 2% of the renewable energy. For example, on industry is there, 100% they are using the fossil fuel. They have to minimum 2% we have to use for this green hydrogen or renewable energy. This means to minimize the global warming and all environmental issues. So these are some basic excellent properties of this hydrogen means. It is a clean fuel with a greenhouse emission. Whereas if you have a diverse, they have a domestic sources like a water, waste, anything, any waste source you can get from the hydrogen, and it is economically competitive. At present, the one cost of this green hydrogen is around 900 rupees. To develop something, it should be make as a economically feasible at less cost. So that is our ultimate aim for any industry anyone is working on. So that is the economically competitive. At present, it will be cost is more, but in future, if we create the facility, if we create the particular facility, automatically the cost will slightly reduce, and they have better security than other commercial fuels. It means the better security than other commercial fuels. If it is a petrol or diesel, you can transport from the one place to by liquid. So this one is you have to compress, otherwise you convert this molecule, hydrogen, into some other molecule. It is a stable molecule and you can transport it for your destination. Otherwise, you have an on-site generation. It means it is a petrol bunk is there. If you supply water to the petrol bunk, there itself you can generate the hydrogen. But whereas a petrol, diesel, you have to get it from the somewhere and you have to store and you have to use. That is the main advantage of it. It means as long as you supply water or waste a particular location, there itself you can generate. So the best example you can generate is the seawater. Is a plenty of water will be there. There you can fix one on-site generation of this hydrogen. Then you can get the hydrogen and oxygen. So that is the advantage. And it is a fast refilling time than a battery. So now people are working for the past 2 years. People are using for the electrical vehicle. Yeah, that's electrical vehicles are good. But the main problem is charging. If charging for a 1.6 kilowatt battery, it needs a minimum 3 to 3.5 hours. Whereas the refilling, whereas in hydrogen, just like a petrol, how much it will take 2 to 3 minutes. Same hydrogen also it will take fueling will take 2 to 3 minutes for the vehicle. So it is an excellent energy carrier. It's having a high energy high distance. So these are the why hydrogen is. This is the exceptional properties this hydrogen is having. That's why all the researchers across the globe, people are looking for this hydrogen. So what is the applications? So what is the applications? Generally, we can look at the transportation. So visibly it is visible. Other than this, the hydrogen is then stored for the different applications from the power sector as well as the industry sector as well as the transport sector. So if you look at this right side, almost 30% of this hydrogen is used in the industry as a surface metal fuel, whereas 7% industry is used in the agriculture and food fuel, whereas 30% is the domestic and utilities, and is a 4% the pharmaceutical manufacturing. So pharmaceutical manufacturing to synthesize a particular molecule where the hydrogen is needed. That type of molecule is 4%. And the reagents and many processes in the chemical industry, there is almost 46% of the hydrogen they are using in the chemical
Hello.
industry. So where is this one? This percentage is the overall
चलो तेरा
percentage. So
हाँ चलो
this is the thing. Whereas in a power
हम्म
sector, how it will, the hydrogen will be useful. So how the hydrogen is, if you go for the telecom industry. So telecom department, what will happen in the as long as the grid power is
upcoming
there,
yeah
it will the signal will be there. Once the
चेन्नई
power is shut down,
webcam bakar
then the telecom towers will run by the DG set, the diesel generator.
हाँ चलो
So with this diesel generator, if you pour the
हाँ
as long as you supply the diesel, so that it will provide the sitting at this water. So we are replacing that diesel generator sets with this hydrogen gas. If you have a fuel cell stack there, as long as you give hydrogen refuel, then it will generate the electricity. So then that telecom towers will be what? So where this VG sets is there in-house, it is a completely now concept people are coming for the net zero house. Net zero house means in your home itself, if you have some portable hydrogen plant, it is as long as your tap water will be connected to the system, and instead of batteries, you can take a small fuel stack. So it will generate the power to your home as long as you supply the water. So that is the one case. This is the home applications. So the next one is the heat and power to the building. So wherever the power is needed, heat is needed at the industry. Now some steel industries or cement industries, they are operating the temperature around 1000 degrees Celsius. So that time, instead of using thermal power, you can use this hydrogen gas. So there you can reduce the temperature and why because it is having a more efficient. So the next one is the industry feedstock. So industry feedstock means in industries where they will use for the ammonia production. So ammonia production also they will use for the synthesis of ammonia. What is the ammonia formula? It is a NH3, one nitrogen and three hydrogens. So only one process is there that is called Haber process for the synthesis of ammonia. So that ammonia is used have a n number of applications for best example is the fertilizers. So fertilizers they will use this nitrogen compound. There this hydrogen will be used. So that next one is the steel production industries as well as the cracking. Cracking means to break that rock. So there you can use it. But the next one is that transport. But in India, the transport of the hydrogen vehicles still not a case. People are working on this a number of places. Like Tata is working, Mahindra is working. So it's a big companies are working for hydrogen fuel cell buses. So recently, Sikri is tied up with some other organization. They got a one fuel cell bus. It is the first time in India it is a full BGS bus is given. In only just 1 week back. So that is the fuel cell buses. In future, it will come. For this any advanced application, where you can use the fuel as the hydrogen. That fuel we can be prepared from the water. So that is the one thing here. I will do this. What is the source of hydrogen? Does not occur free in nature. So it is an energy carrier. Already I told it is available in the water, it is available in alcohol, it is available in natural gas, it is available in coal, and It is available in all biodegradable items. So these are the next. So in future, now the renewables and nuclear will be a significant source of the hydrogen in future. That's what we are going to discuss. The renewable. And so hydrogen is the secondary source. This generation of hydrogen is basically classified into three types. Any method in the world is at present only three models. One is steam reformation, another one is cracking, and third one is the electrolysis. So these are any developing method is comes under this one. These are the three umbrellas. One is steam reformation, is the old method. At present in India, the one US company is there. So they delivered per day 80 tons, 80 tons per day of the hydrogen by using this steam reformation. It is a old technique, but it is at present people are using this technique is the steam reformation. So the next one is that is called is steam reformation is heat followed by thermolysis and you can get the hydrogen. So the next one is the cracking. So cracking means to break something, to break some molecule. So it means to cracking this one, there design a separate reactor and there people are working a particular catalyst to break the particular. For example, if you take ammonia or methane, to break this carbon hydrogen bond in ammonia, that's methane, to break this bond, carbon and hydrogen, to break this temperature, you need a particular catalyst. So that's called as the cracking. So these are the new technologies. Whereas the bottom two, cracking and electrolysis, these are the new technologies in future. Now at present people are working on the identification of the suitable catalyst, at least a low cost catalyst to break this molecule to get the hydrogen. So this one, it is a mechanical energy and electrolysis. Electrolysis means by applying some particular potential to break the molecule. It's called as the electrolysis. So the next one is the conversion technology. So conversion technology means there's a conversion followed by the fermentation means. Conversion technology means, for example, if you take any carbohydrate waste, it is a food waste. Food waste it is a carbohydrate. If you add to food waste, the carbohydrate with the water, it will generate some carbon dioxide as well as the methane and some other products. What is the methane is available? That methane you can do the cracking and you can do the hydrogen generation. That is called as the conversion technology. The next one is the photolysis. So this electrolysis is comes under if you done in presence of light, that reaction comes under photolysis. Photo. So these are the basic generation methods for the hydrogen. So what is the what? Among these generations, now our team is the Nanosol is exclusively working on this electrocatalysis. In this electrocatalysis, we are working on the electrochemical techniques. So this is the first one. What is the water splitting? Water splitting is nothing but HOH part. To break that oxygen and hydrogen, we can generate the hydrogen gas as well as the oxygen gas. So at present, before corona, people are only concentrated on this hydrogen gas. But after corona, people are also looking for the capture of this oxygen also. Why? Because if you split the water, you are not adding any ingredients or any other chemicals for this reaction process. So you are getting only hydrogen back. So this is the high pure hydrogen and oxygen. Only electrocatalytic technique
Sir,
only. Yes, sir.
sir, please check your audio. Is got to adjust that audio.
Okay, okay, sir.
It's not sharp.
Hello. Yes, sir. Now it is audible.
Ah, raise your
Okay.
sound. That's okay.
Okay, sir. Okay, sir. So this is the thing. So to break this bond, oxygen and hydrogen bond, we need a three techniques is currently available. That is electrocatalytic water splitting, photoelectrocatalytic water splitting, and chemical oxidation. So among these three techniques we are adapting. The first one is the electrocatalytic water. Why? Because whatever electrocatalytic water splitting and chemical oxidation, you cannot go for the pilot level. You can go for the small industry, small lab scale industry, but you can go for bulks. So that's why we have to this electrocatalytic water. So why you are using this water electrocatalytic already explained to overcome the inability of the batteries and super capacity large scale energy sources. If we go for on-site generation, for a battery, it occupies more space. If you go for this 10 kilowatt or 50 kilowatt or 100, if you go for megawatt, it occupies a lot of space. Yet to that, the batteries manufacturing. That means we have to import, and in India, the only three places are there, they are manufacturing the battery. So we don't have a raw material. India don't have a right to get the raw material, and India don't have facility to make the batteries. We have a facility to make the batteries. We cannot. We don't have a facility to make the cell. What is the cells we are using in the battery? That cells we don't have. That cells we are importing, and we are making the battery pack. And the cell pack we are making. So the next one is that to afford the future with a greener fuel from the endless sources. There we can get the hydrogen and oxygen from the CO. So once after 3 years or 5 years, this electrical battery is there, we will go for a scrap. The recycling process is a very dangerous. Why? Because we have a heavy metal. So whereas in the fuel cell stack, what we are developing, there once it is after 5 years or 10 years, just you can replace the stack. It is a reuse. Once you make that membrane outside and you have to wash it again, you can use the same metal for n number of times. So that is the advantage. So the next one is to enable the large scale electrical energy storage in the chemical fuel. You can store how much we need based on the deposit. So to keep in this mind of all these things, just recently we worked on this one for the from 2009. From the, myself and my colleagues both were working on for the 2009 and till 2021 where we'll work this. We have expertise almost 13 years for the, from the fabrication of catalyst to assembly of the cell. So is any water electrolyzer consists of few is a common component like so we need a first one is the input of the water. So we have a deionizer plant. So the next one is once the deionizer plant will be there, it will deliver the water. So they deliver water, it has to go uniform way. That's why you can use for the metering pump. So once it the pump will be there, and the next one it has to heat the water. The second case, from the first case, what will happen? The deionized water purified to it will come to the pump. From the pump, it will go to the heater. So the heater, what will happen? It will keep the temperature around 85 degrees centigrade. And once this water will be heat, and why? Because if you pass this cold water to break the bond, it is very difficult. That's why before entering to the stack, what will happen? It will enter into the stack for the hot water, and you can observe this one. There you can get the bubbles followed by some water evaporation. This is called oxygen, and the backside will be there. It is a hydrogen. So this backside hydrogen will go upside. There we can go for the here we can give us some a gas liquid separator. Why we are giving the gas liquid separator? As long as gas is entered here, so the hydrogen will be go out. Why? Because it is a less dense, and what will be having high density, it will be come down. So the gas will be good. From this place we can store the in a particular container. So that is the container, and we are using the two pressure gauges. One is for the water, how much pressure is there inside the stack, we have to optimize, and the next one is the hydrogen, how much hydrogen is there, you have to optimize by using the pressure gauge. We have to know how much pressure is there. The next one is the stack. So, the my talk is to fabricate, to design a developing of the particular PM water electrolyzer. Now to split these things into two parts. So one is two phases. First phase is the stack preparation. Second phase is called as the power electronics. We have a heart. The remaining things we can be uh, arranged based on the stack. So the first one, it is a stack. The stack, it consists of the core materials again inside the catalyst. So that is the heart. Why? Because that is the surface reaction. So once the as long as the water will touch the surface and it will split. So if you have a good catalyst, it will be split 100% efficient. So if you have some normal catalyst will be there, moderate catalyst will be there, it will split by 50%, 70%. The efficiency of this cell, the efficiency of this cell, it will depend upon the catalyst. That's why have to identify a suitable catalyst. Then this catalyst should be made as a membrane electrode assembly, and followed by we have to make it some stack. It is a complete design. We have to design the stack. It means the water enters the flow channel and we have to go for the test. So it means once you make the stack, you have to check with the leak. If any water leak will be there after for the several hours. So once the stack is ready, so then you have to send this water filter. So these are the part who is there. These are the some things it will be there. Every electrolyzer. These are the common things. It is a deionizer or purification unit, and it is the metal form, and it is how to give a regulated power supply. The power supply is put from this renewable sources like a solar, wind. That depends upon your place, and you have to control the temperature, and you have to go for this do all these things we can call it as the power electronics, followed by you can both the things you can assemble and you have to test. So why we can call it as a PEM electrolysis? PEM means a proton exchange membrane. Here you see one membrane where it will exchange the proton from one place to another place. That is anode to cathode. It's called as the proton exchange membrane electrode. So at this, what are the catalyst you are using? The anode, water will be split into H plus and two electrons reactor, whereas the cathode is a 2H plus will react take from the two electrons from the anode and it will generate the hydrogen, whereas the anode it will take the oxygen. So this is the overall chemical reaction occurs at the catalyst surface. So that is the catalyst as well as long as it provides a low cost and that high efficient catalyst. So the overall efficiency cost of the cell is depends upon the availability of the catalyst. Okay. So at present people are using a platinum related catalyst as per this what splitting. The platinum is a costly. If you bring at the people are working across the globe to replace this platinum catalyst with an carbon powder or some other heteroatom group materials or graphene materials and functionalization of graphene materials for the replacement of this platinum. So once if the replacement is there, the cost will be decreased another 50% of the existing electrolytes. So that is the catalyst. So these are some properties. If you come across the material chemistry, these people know about this. What is the over potential? What is the tap and flow? These are some parameters which should be identified. So if you take any catalyst, if you follow these properties, then you can directly come to as a it is a good catalyst for the water. So these are the properties using our PhD for the past 10 years. We start out. These are the points. If these have good characteristics and this catalyst is follow these properties and it is a good for the electrocatalysis. So these are the properties we identify. It should have a low over potential and it should have a low tackle slope and the ability to withstand accelerated degradation and good stability upon galvanostatic studies of for 24 hours or more than that. And it is having a high mass and specific activity. That is called electroactive sites along with this one. And it has a good Faraday resistance. If the material is wants to develop anyone is following these criteria, it should be a good for the electrocatalyst. So these are the water spreading mechanism. It's taken in the two places. Where this is the left side, it is called as the stack. Where this stack, it is a looks like. What is the stack? This problem. What it is there? This one. This stack is that basic diagram is this. So it contains a catalyst layer followed by This is the water, hot water will be injected inside, and this is the mechanism. Once we enter into the hot water, where is the blue dot? The red is the oxygen, remaining is the hydrogen. Once it will enter into the, as long as it touches to the electrode surface, as long as it touches to the electrode surface, where this oxygen will combine with another oxygen, one side will go out, whereas the cathode will be in half. Once the proton is transferred, one proton is as associated as reacted with another proton, and it will generate the hydrogen. So, previously people are looking only for hydrogen. Now we can get the pure oxygen. The purity of this hydrogen oxygen is 99.29. This is the only technique at present. It is providing high pure hydrogen and high pure oxygen. So these are the two mechanisms. So this is the stack assembly. What I showed the part, what is the stack, this part. This part is a complete part. It is split into the different places. One is called as the end plate and followed by the current distribution. There is a lot of micro channels there. You can do for the CNC machine for this one. This is the current distribution there. And there is a followed by the low channel and there is a gas diffusion layer. There is a cathode gas diffusion layer as well as the anode gas diffusion. So once the gas diffusion layer is there, at the edges it will be gas type. It means it should not be, it should be a airtight and watertight. So that's why we can use for the cathode gas. Once you coat on the material, same thing we have repeated for the anode. So the catalyst, what we are coating on the anode side and the cathode side should be based on our application. We can choose the catalyst. So where the surface reaction will be happening. That is the nanomaterial. This is the overall system. At present, it is a the capacity of this one is a 3 liter per hour. It means 3 liter of hydrogen is generated per hour. Now, same thing we have next level we have automation. It means it is a we have to in future. So we are at present we are working. It means you have to download an app. There you can control all the systems. That is called automation. We are going for the next level for the large. So that is we are working at present on this. So this is the what is the uniqueness of this PEM electrolyzer? It is a costly design. What is the uniqueness? The uniqueness means once the PEM electrolyzer is working condition is the 5,000 hours. It is a more than that. Even though after 5,000 hours also you don't need to replace the system. Just to replace the catalyst means it is a reusable catalyst you can use it and you can pay. The remaining system is as such. So that's why there is a direct conversion. Now, it means the water is directly converted into hydrogen and oxygen and easy to operate and maintain. It means you don't need to go for any maintenance and it gives high pure of hydrogen and there is no high temperature reaction to break and all these things. It is easy to operate and it is a good energy saver and it has a good returns. So these are the overall thing of this PEM water electrolyzer. So what is the services? What we will do? Already discussed about the fabrication of customized equipment and hydrogen generation plants, reactors, and anything for the design. If you have any plan for the large scale, we will, there is expertise team will be there. These are our expert team. At Nagmahesh is that myself is the co-founder, and Sarda Prasad sir is the process engineering, and whereas the P. Nandakumar sir is the fabrication expert. Both these are having almost 35 years of experience for the designing and fabrication. So these are working for this very big industries like the BHEL and in Engineers India Limited and large companies they have already delivered some reactors and the product. So all this team along with our technical team, so many people are there, we are making for the cleaner future. So this is our things we are working on this waste to energy conversion. So once again, thank you to one and all for your patience and thank you
Yeah.
Rajkumar sir for
Yeah.
your team.
Yeah, yeah, yeah. Thank you very much, Sankara Rao, Dr. Sankara Rao. Uh, Audience, if you have any discussions or doubts, please discuss with our expert.
So this is my mail ID. Just
பத்மா பாப்பா கூப்பிடு நான் பேச போறேன் பத்மா so
mail ID.
yeah, yeah, two questions is available in our chat box.
Yeah.
Just I like to read from Sudam Sankar Badi. He is asking up to what extent we can use seawater as source of hydrogen generation.
So seawater, that is the different. It means based on the electrolyzer stack, that everything depends upon the size of the stack. If you increase the size of the stack or if you increase the area of the electrode, as long as you attach the water on the electrocatalytic surface, that much of hydrogen we can generate. That is the based on how, just based on our requirement, we can fabricate the stack.
Okay, another one question from Amisha J. He is asking what is the efficiency of hydrogen fuel? Like how much energy will it produce per liter of the fuel?
It is for the as long as the petrol it is a 40, it is a 120. It is a three times higher than existing fuel. This energy efficiency.
So he is asking another one questions like if we
Yes, sir.
use hydrogen as fuel in vehicles, should we replace the engine or whether it works with this same engine?
No, no, no. Here we cannot use the engine at all. In the replace of engine, we are using the fuel cell stack. That is the fuel cell stack. As long as if you supply the hydrogen to the stack, that fuel cell stack will generate the electricity.
Uh,
Here there is no engine. In
okay.
the battery, we are using the battery. For a hydrogen, whereas we are using the fuel cell stack.
From Wasiuddin, he is asking how can we prepare a small PEM electrolyzer in
Yeah, this
our
is
lab
what this
for
is
hydrogen products.
what
Yeah.
yeah, what is the I showed it is the small one. That is the small 3 liter per hour. You can go for the 1 liter hour. Decrease the size and you can do it. The components is same for the water products, PM water products.
He is also asking one question: what type of stainless steel used as cathode and anode in PEM?
Yeah, so you can use for the SS304, SS316. Different grades are there for SS material. So based on that things you can use. That is the
Uh,
composition. There is
one,
a SS304 is there, SS316 is there. SS, there is a numbers will be there, different grades you can. But here we are using as a SS316.
so one more question from Sivachandran. Uh, uh, for in presentation compared to river water, why sea water is salty? He like that. He is.
Yeah, that is that
Yeah.
is obviously different. As a C1 is there. Just that
Uh,
the composition is different from the river water.
okay.
That is
So another one
any other.
question from Arul Murugan. What is the best catalyst that can be affordable easily?
At present, there is only one catalyst. It is a platinum dope catalyst they are using. So the next one, now the people are across the globe, they are working actually for this catalyst. I didn't get the suitable low cost catalyst. Now it is the platinum doped carbon. So,
I think no more questions in chat box.
yes, sir.
Thank you very much. I have some small questions from
Yeah, yes,
your
sir. Sure, sir.
presentation. So you mentioned different method to generate hydrogen, right? So
Yes, sir.
biomass, photovoltaic steams, photo, biological, so many methods.
Yes, yes, sir.
Which method is most efficient and
No,
which is
efficient method
not
means
only efficient because we need to use commercial, right? So commercial is very important for hydrogen generations. Still now we are struggling for have, generations of hydrogens in commercial as well as storage of hydrogen, right? So
Yes, sir.
just you
Yes, sir.
just
This
give
at
some,
present,
yeah.
India, so many industries are they are using for the steam reforming process. So steam reforming process they are using, and it is cracking and electrolysis. These are the advanced technologies at present they are working. Future
Okay,
it will be.
okay. So still now we need to develop
Yeah,
more
yes, sir, yes, yes, sir. At least
hydrogen
after
generation
5 years or
catalyst,
6 years,
yeah,
we can come
catalyst
across.
as well as technologies also, right?
Yes,
Because hydrogen is not easy to storage and is not easy to transport from one place to another place, same like gases. So this that is the it's very interesting and very important field for clean energy technology, right? So
yes, sir.
because nowadays many researchers in worldwide they are doing many clean energy field like water splitting and biomass, so many things. So this is very
Yes, sir.
important field and we need to focus in this field in India also, because we have a very limited research groups are doing hydrogen generations. So we need to focus and we need to develop many catalysis and
Yes, sir.
storage systems also. Yeah, yeah. It's
Yes, sir.
it's nice to see your presentation.
Sir, thank you,
Yeah.
sir.
Any other
Okay, sir.
questions, discussions from audience? Please, you can unmute and then discuss with experts.
Chandra, I
Please.
have one question. Hello, am I
Yes, sir.
audible?
Yes, sir.
What is the criteria to select the catalyst
Yeah, there already I
while
told some
using?
parameters like low over potential, high paratic efficiency. So it should have a tap and flow. These are the some theoretical parameters. Actually, you have to do it before the catalyst. You have to choose the catalyst. There is electrochemical experiments you have to do to assess the catalyst. That is called option reactions. You have to do this. For what is the only hydrogen evolution reaction? What will happen? And oxygen evolution reaction? What will happen? So keep on. We are working for this almost 5 years. We are working in this circuit reaction and we optimize these properties. Any property, not only for the many people there follow this.
Can we use perovskite related material?
Yeah, yeah, you can use it perovskite material. But perovskite material is the light sensitive material. They have to work. Yes, recently they will last for the past 5 years the perovskite material is used. So you can use for this one as the efficiency how this one. Now they are working for the solar, I think, and they will move. Not at move. People are not moved to this one, and they are moving. But in future it may happen once he is assess this problem.
And last question is, are you started the production related to
Yeah,
this
yes, sir.
instrument?
Yes, yes, we started. Yeah, this is already we delivered. We already delivered to the Telangana government renewable energy, and we started. It is a market ready product.
Okay, okay. Thank you.
Okay.
I
Any other
think,
Thank you.
questions from
yeah,
students?
one more question in chat box from Jayashree. She is asking hydrogen storage is difficult. What we can do for that? Yeah,
Yeah,
that.
that is a hydrogen storage. That is a different research,
Yeah,
but
this is
they
not
will at
simple
present.
question.
Yeah, it is a thing. Metal hydrogen tanks they are using at present in India to store the hydrogen. So that's why I told if you want to transport from one place to another place, they are converting this hydrogen to another molecule, stable molecule. There in the on-site generation. That's why we came this one is the on-site generation. As long as the where the water is supplied, there you can generate this one hydrogen.
I think no more question. From Karthik Chandra Maskili. He is asking why is basic criteria property present in the catalyst?
Yeah, that is the heart of the thing. You have to do it. There is no action except you have for that one.
Yeah.
Once you follow this one, then only surface gates will break them.
So any other questions from audience? You can chart. You can, yeah. One more question. What is the advantage of photocatalysis over electrocatalysis
The
and why?
photocatalysis you cannot go for the bulk scale, whereas the electrocatalysis you can go for the large.
And why electrocatalysis is preferred for water splitting?
Yeah, that is the properties already. Same thing I told. This is the property. The catalyst, they have the over potential happens. So any catalyst material, any nanomaterial, all of these properties. That is the catalyst.
For the
Photocatalysis is nothing but the catalyst should be active at present in terms of light. That is a photoelectric effect. But there is a separate source will be there for the light. Whereas in the electrocatalysis, it's the renewable energy only we can use.
so any other questions? Any other questions or discussions?
Whether your company is supporting for scientific research people,
Yeah, we will do it, sir. Just you draft
taking
anything that mail, you can respond it.
taking measurements like that with the charges.
Yeah, you can do it, sir. You can do it anything is